give you time, y'all. I need to give y'all time to be able to do the opener. There's multiple grades today. The opener is treated as a separate assignment worth 100 points. I updated my grade book like crazy when I had I didn't realize I had a sub the back half of the yesterday until morning, literally during the first period yesterday. And that was the very first thing that I did was I updated my grade book. I do have some papers that I need to pass back, which if you've done them online, I marked out the ones that were incorrect that were submitted online. Tiffany. Okay, because this whole, are they positive or are they negative? Do they gain or do they lose electrons?
What did I make a 38 on?
One of these. I don't remember which one, but you weren't doing this one. You weren't doing something right, and I know with online, I can, yes, you would need a periodic table. One of these days, I'm going to learn where everybody's sitting, but that is not today.
This spreadsheet?
Yes.
Is there anything I'm giving you do this?
I mean, hold on. Let me finish passing everything out first. I actually learned your names so much more from passing back papers, and with everything being so digital, it's just messed with my ability. Plus, I'm not used to having 240 students. I'm used to a lot less than that. Let me double check attendance first. Jared, let's see, Lana.
No.
Okay, hold on here. So you guys have your thing to do anyways. Online, the opener. Let's see, Sahara, Tiffany, Lucas is here. Tatiana, Jimmy, Sebastian. What's the matter now? Which period number is it working in? That's what it is. Like how you have a number and then a letter and then a superscript. That first number is the one that it's working in. So which one is the outermost? That's what it's asking. Okay, hold on. I don't see Kyle, I don't see Matthew, and I don't see Bailey. And I'll double check online if you are there. I'm just not looking at it this second. Veronica, I think I already saw online. Valerie's here. See Robert. We keep switching people to remote, and this is really messing with me. Mia, Reagan, Aiden, you're here. Have you been following along? Well, you weren't here for a couple days. I don't remember specifically which ones they were. You weren't here, what, the 4th? Okay, but did you see everything in Canvas? Okay, because your mom has been back and forth with me. So, Raiden, like I said, if you guys are online, I'll get to it in a second. Eva. Okay. Yeah, I have other papers to pass back. Hey, Veronica, I can give you your paper through the computer screen. It's easy. Just shove it through the computer screen and it goes through, huh?
I don't know how to do it.
Okay.
Open it.
Veronica, I can't give you your papers. Please. So these two I can't get to. All right, so because I can't remember the order of the questions. They're all about chlorine, and they're all the same. Then I gave you the electron configuration of chlorine. Let me open up the actual question because I can't remember specifically. I need to go into edit questions. Okay, so I gave you the electron configuration of 1s2, 2s2, 2p6, 3s2, 3p5. I'm not trying to trick you. That is all of chlorine's total electron configuration. The first one, I have to go into the edit. What is the outermost energy level of chlorine? Which period is it filling? In English, it means, because you have, if I, you can't see it. Here, I'll put it on the, I don't, copy, go in here. Let me see if I can paste this directly over here. Paste. Unable to create some images. Okay, I'll just put it down underneath it. 1s2, 2s2, 2p6, 2, 3p6. And then I'm not going to just tell you the answer, but I can help. Because I've noticed, okay. Let me unfreeze it. Now they can see what I'm doing online too, because I should be pinned. Let me make sure I've pinned my thing. Yes, I have. Okay, so this is the full electron configuration of chlorine. I'm not trying to trick you. You have 3 parts to electron configuration. You have the period that you're working in, the cloud that you're working in, and how many electrons or elements over you've gone. And you got to keep going. So, that's supposed to be a 5. It's just, I wrote it wrong on mine. That's 3p5, not 6. That's my typo. It's not messed up in Canvas. I just wrote a wrong number. Let me fix it. Present. Let me fix it. That's my bad. I apologize. That's what happens when I do things last second like that, because I constantly make mistakes. I have to go back and fix them. All right, so it wants to know, what is the outside shell? Which period is it working in? Which is the active shell that it's working on? That's what that means in like English, outermost energy level. How many valence electrons does it have? When it makes an ion, what will happen? Remember, if you lose electrons to normally go down to 0, then you become positive. That's what I noticed you were doing wrong, Jared. That one paper, like if you lose electrons, you become positively charged. Normally you have 1, 2, or 3 valence electrons to do that. You want to go down a shell, down to 0. If you gain electrons, which means you have 5, 6, or 7 valence, then you're going to gain however many electrons you have to bring in to go up to 8, which is, I know there's an exception. That's how negative you're going to be. This wants to know, what would chlorine's oxidation number be? You should have put those on the top of your periodic table. Does it gain or lose electrons to do that? And then how many total electrons does it have once it becomes its ion? Like total, not just the outside shell, all of them added together. So hopefully that, yes, there are some extra answers that aren't the correct thing that are down at the bottom. Okay, now what we are doing is I'm going to stop presenting, and I am going to go to the right slide if I can find it. Chrome tab. All right, we have a ginormous Google slide today. Well, it's not hard. It's just a bunch. It's not hard. It's just a bunch. So now I'm not about to answer all of these, but I will go through a representative one. If you've not done it, go into Canvas, which they can't see what I'm doing. You guys can. And after you've done the opener, it's just Google Slides. Now, if we have time, we're going to do this Mr. E activity. I don't know why I'm hearing music over there. Turn it off. I did this pretty quick, but I know the secret behind this. So, Jared, turn it off. I'm going to go into Relay and control all of your stuff. But this is the one you want to pull up. It's going to make a copy, and you can submit it. I need to change this so that I can write, if I can write on this. So, first slide. I'm only going to do the top one. Write the element symbol and the ionic charge. I know it has 12 protons, and it has 10 electrons. I need a periodic table. First of all, which element is this? And how do you know it's specifically that element? It's the proton. So which one is it? Magnesium. Okay, what is the symbol for magnesium? Mg, capital M. Now, I did not take off for this. If you had them both lowercase, I should have counted it wrong. If you had them both uppercase, I should have counted it wrong. First letter is always capitalized. If there is a second letter, it is always lowercase. So once it makes an ion, first of all, it's in group 2. How many valence electrons do things in group 2 have? 2. Is it going to lose 2 electrons, or is it going to gain 6 electrons? It's going to lose 2. So if you lose 2 negatives and you were originally neutral, what is the charge? plus 2, besides the fact you were supposed to put the oxidation charges on the top. So its charge will end up being a positive 2. I noticed, and I think it was actually 8th period that I noticed this in more than anything else. They had the right number of valence. But in this case, they said, oh, yeah, well, it's going to lose 2, and it's going to have a negative 2 charge. Oh, they're neutral. You're either gaining or losing a negative charge. So if you lose 2 negatives, you've now become positive by that many. Positive charges have lost electrons. Negative charges have gained electrons. I guess I didn't make that 100% clear, but you guys can do the other two. If I go to the next slide, just doing a representative one on each one. And it's y'all's job to do the rest of it, and you should be able to finish. Because it's not hard, it's just a bunch. How many electrons were lost or gained to form each ion? Aluminum has a positive 3 charge. It's in group 3. It has 3 valence electrons. So in order to get to positive 3, it had to lose, or it lost 3 electrons to become positively charged. I don't mind stopping and doing a big Google slide like this, because this is a review over like 4 sections of notes. But you'll have a test sometime next week. The stuff that we're going to start tomorrow, these Lewis dots with ionics, they're a little bit more complicated. Ionics are easier than covalence. I will tell you that. So that you're going to do that for this slide. The next slide, how many protons, electrons, and neutrons? We have an ion here. This is telling you basically the isotope information. Do you remember what the top number is? That's the mass number, not the average, because those are decimals. What's the bottom number? Normally the number, always the number of protons, period. So I know aluminum has 13 protons. That never changes. Change proton, change the element. Now, if it was a neutral atom, it would have 13 electrons, but this says positive 3. So how many does it actually have? 10. So maybe this helps. For those of you that are getting it backwards, you have 13 positives, you have 10 negatives, you have 3 more positives than negatives, so it is a positive 3. How many neutrons does it have? How do you do that? You subtract, and 27 minus 13 is going to be 14 neutrons. And you'll do that for each ion. Remember, if it's a negative charge, it has that many more electrons than protons. Positive, it has that many more protons than electrons. You just can't change the protons. For each group, write the number of valence electrons. I'm not going to do that. You get this straight off your periodic table. I'm going to want for group 1, group 2, how many outside shell, not charge, how many outside shell electrons does it have? Group 3, 4, 5, 6, 7, and excluding helium, group 8. That's why this arrow goes down from neon down, because helium's an exception. Helium has 2. It just falls in the noble gases because its shell is filled, which should have told you the answer to that one. Valence electrons, fill in the blank. A couple of them are already put there for you. That I'm not going to do for you. How many valence electrons? Find the P. Find phosphorus. Which group is it in? No, count again from left to right. Count over. It's in group 5. So how many valence electrons does it have? It has 5. And it's easier, not that this is the question, but it's easier to gain 3 than it is to lose 5. It does the quickest path. And so that's why group 4 sometimes is positive or negative 4, because it's right there in the middle. Electron dot diagrams. Complete the electron dot diagram. So I'm not going to move the dots. Find silicon. And first, how many valence electrons does Si have? 4. So how many dots is it going to get?
4.
Do you remember how they go?
Yes.
Do you want me to put it back on the board? I personally am not a stickler for the order you do it, as long as you make sure. So this is your element. It should be right, left, should be top, bottom. And then you start doubling it up. Now we always do this one next. Really? Like, if you put one, not that this is this element, if you put, as long as that one has 2, normally we go clockwise. So 6. This would be 7, and this would be 8. But I'm not a huge stickler if it's not perfect going around. But each side gets one before you double up. And we always double up on the top first. I know it's hard to put the dots on stuff unless you've had Cami and you can actually like use a pen, right? Doesn't Cami give you like the pen option where you can make the dots that way? Some of you hate Cami. Some of you love Cami. Okay, so I guess I can do one of them for you since, so we said that silicon had 4. So where should the dots go? So one on each side. Oh, I don't want that one. Oh, no, I don't want 2. It's duplicating it. Okay. I didn't do this. You can blame Miss Castleberry. She's the one that puts together most of the Google Slides. We all do something different. Sometimes one person creates the module and we link all the notes. Just whoever's more on top of their game in the weekend is going to be the one that does it. So you're going to do the same thing for potassium, fluorine, and phosphorus. Which periodic trend is described? This was yesterday. As you go from left to right, the sizes of atoms get smaller. We call that a radius. As you go from top to bottom, the size of the radius gets larger. This isn't exactly this question, but also from left to right, the energies and the electronegativity, you go left to right, they get bigger. Noble gas does not count there because they're inert. As you go from top to bottom, electronegativity and the energy gets smaller. Noble gases are excluded because they are inert. Now, the energy required to remove an electron is going to be one of them. I just basically told you. The distance from the nucleus to the outside, there's only one of them that has that right word, not diameter, it's the other one. And then the ability to attract electrons for bonding. I will tell you one of them and you'll be able to figure out the other. What electronegativity means is it wants to gain a dang electron, which is why group 7 is the most electronegative group, specifically fluorine, because he's the top right. That is what electronegativity means. It wants to gain an electron really, really bad. Ready, the trend, I just went over these with you. For each pair, circle the neutral element with the largest atomic radius. This is also trends. Which element? Looks like 2 of them were filled in. The halogen that is liquid at room temperature, that is actually not right.
Did you do it?
No. Miss Castleberry did it. Well, I did. I took it from her and I put my name on it. This is not right. This is not iodine. Which group 7 element is the liquid? Yeah, you need to change that. This one is right. The most common element in air. Now I understand why she put that there. 80% of what you breathe is nitrogen gas. Actually, it's 79%.
What?
The most common element in air, that one is right. The iodine was not right. That was bromine. It's bromine, Br.
It's connected right here.
This doesn't matter. No, that's not. Are you talking about the staircase? No. That has, no. No, I don't understand. So, but no, leave that bottom one as nitrogen. That is correct. Let's see if she made a mistake here. A nonmetal with 1 valence electron, there's only 1. The dense metal named for its use by Romans. This is right. This is plumbum. Leave that there. The largest atomic radius of all period 4 elements. You can do that. Alkaline earth, metal important in bones and teeth. Calcium is correct. So leave those 2 there. And then once you're done, you can submit it. Now, if you finish this, there's something else in Canvas. And I think I'm actually going to do this guy.
What?
This guy, Mr. E. Because some of you are probably almost done with the Google slide. It's not hard. It's just long. Okay, so you didn't even start yet. So we need to wait for Mr. E then. You can try to do it. I guarantee you're going to get stuck. Okay, so we have all these cards. Okay, they represent, they're stick figures, but they all represent something different. It'd be easier if you separate them out. You have to figure out how they're representing elements and put them in the right place. And then you're going to have one blank that's left behind, and that is the Mr. E or mystery element. This took me a little bit of time to figure out, and I know the secret. You have to actually think for a change. They put, this guy belongs here, this guy belongs here. Don't move them. I will give you a hint. Look at how many fingers they're holding up. Look at how many hairs they have, and look how big their bodies are. And that will help you organize them. And also the pattern of their body helps too. It'll help you organize them and put them in the right place. But what I want you to focus on now, obviously do the opener if you have not, but that Google slide is what you should be doing. And if you're truly stuck, okay, I'm not just going to answer everything for you. I need to delete all this stuff out for 8th period. That I can try to help you, but I'm not just going to feed you the answer. Oh no, I hit a wrong button. Jared,
What?
I can hear it again. Are you kidding me? I am not deaf.
How can you do
I have an 8-year-old. Like, I can hear things.
that?
What do you mean there's no way? I am not deaf. When there's too many noises going on at the same time, I have a hard time hearing them. Jared, it's still going on. I'm about to take whatever it is from you or write you up. Yes! Yeah, Jared, and pull your mask up over your face like you're supposed to. Let me make sure that the rest of this was put back the way it was supposed to be. Jared, I'm just about to write you up and just let them take care of it. Because I've asked you nicely how many times now? I said turn it off. Are you lying to me? Okay, I am going to stop the recording. Oh, I see other people online. I'm going to get you guys in just